Hi all, and welcome to my discussion on correlation and causation. These are two words that are really important in science, and there are a lot of adults out there who would struggle to really explain or give good examples of the difference between these. So pay a bit of attention, and hopefully at the end of the lecture, you'll be able to school someone in what the difference between correlation and causation actually is. Correlation. A relationship existing between things or between mathematical varies which tends to vary or occur together in a way that is not expected on the basis of chance alone. In other words, if two properties or events are correlated, this simply means that when one changes, the other tends to change in a consistent manner. Things can be positively correlated or they can be negatively correlated. In other words, they can go up together or they can go down together. Here are some examples of correlation. As algae increased in a lake, a certain species of algae-eating fish increased. This should make sense. You would think to yourself, these are algae-eating fish. If there is more algae, they will be able to more effectively produce offspring, and those offspring will go on to eat algae and produce more offspring. But I'm going to tell you, until you've done repeatable experiments, this is correlation alone. There could be other things that could be causing the algae increasing fish to multiply. What if what you didn't know was that the oxygen level in the lake went up? Because in other portions of the lake, a thing called eutrophication, which suppresses oxygen, is being dealt with. Thus, more oxygen, more all kinds of fish, not just your algae fish. Sometimes when we look at an easy correlation, we jump to the idea that the increase in algae caused the increase in fish. Until you have actual scientific proof, these are causally related. The longer your hair grows, the more shampoo you will need. Think, maybe that's true, but maybe you'll use approximately the same amount of shampoo no matter how long your hair grows. Maybe you're the kind of person who likes to have tons of shampoo or conditioner in there to really get your hair extra clean or extra glossy. There are lots of reasons why you might or might not use more shampoo, though most people, the longer their hair gets, the more they'll use. The more gasoline you put in a car, the further it can go. Again, what if between fillings something happens to your car and so your car suddenly doesn't go as far? Is it because you didn't put in enough gas, or is it because you have some kind of a friction event in there that's causing your car not to be as efficient burning that gas? Again, generally, more gas in, farther you can go, but there can be other reasons why your car goes farther or not as far. Causation. This means X causes Y. So before we can go any further and talk about causation, we want to look at the difference between cause and effect. A cause, something or someone that produces an effect, result, or condition. Something or someone that makes something happen or exist. Effect, a change that results when something is done or happens, an event, condition, or state of affairs that is produced by a cause. This is super easy, I promise. Let's take a look at an example. Meet Janie. Janie is in second grade, and she decides that she's going to try to blow the biggest bubble she possibly can. All of you know what the effect of this is going to be. Janie's bubble bursts in her face. Janie does an action. Her action directly causes the bubble to burst. So this is cause and effect. Action X makes action Y occur. Causation examples. If a person is decapitated, death will result. The direct cause of death is decapitation. Gravity. Gravity pulls objects downward. If you drop an object, that object is going to go down. And the reason it's going to go down is because it is attracted towards the largest mass, and that force of attraction is gravity. Gravity causes the object to fall. There are many other examples of causation and correlation. I'll give you a moment to think if you could come up with some. Correlation versus causation. Here's the rub. Just because two events or properties are correlated, linked, does not mean that one causes the other. Here's one that's going to be maybe hard for you to hear. Smoking is correlation with lung cancer. Think, there are other ways to get lung cancer. You cannot have smoked a day in your life and you can get lung cancer. You can never have smoked a day or you can have smoked every day in your life and not get lung cancer. Now, if you smoke, are you much more likely to get lung cancer? Of course you are. They're correlated. This one action affects this other outcome, but it does not always cause it. There are other reasons for lung cancer. So if we're looking at a very specific case, say case X, and that person has lung cancer, and we can rule out all other causes, then we could say that lung cancer causes the cancer. But it's really unlikely that you can rule out everything else. Think, maybe that person lived in a city where there was smog. Smog is correlated to lung cancer. Maybe that person had a job where they breathed in particulate matter. Particulate matter is correlated to lung cancer. The fact that they smoked is just one of the contributing factors that gave them lung cancer. They are correlated. They are most likely, the more you smoke, the more likely you are to get lung cancer. So here's some other ones. Going to the hospital is positively correlated with dying, but you know that when you go to the hospital, they're trying to save you. It's just more likely that you're going to die when you go to the hospital than on any other given day. Those are correlated, not causative. The more firefighters at a fire is positively correlated with the amount of damage done. Obviously, firefighters are not causing damage. They're there to mitigate damage. And so just because more firefighters equals worse fire, that's correlated because generally more firefighters are called to a larger fire. Here's a silly example of correlation versus causation. I want you all to consider in your future life becoming pirates, because global temperatures have risen in correlation with the decline in pirates. So if after 2020 we all go out there and start being pirates, global temperatures will naturally fall. Hopefully you understand that this ridiculous example is meant to show you that just because I can put two things on a graph, just because I can show you once and for all that the cause of global warming is the decline in pirates, doesn't actually make it true. So I hope that you'll take this example away with you, and I hope that you will think about the difference between correlation and causation, because it's really important. If we get them wrong in science, some really bad things can happen. We can make wrong judgments about things. Probably one of my favorite examples is autism. There was that terrible study that was done that said that vaccines cause autism. We now know that that's total and utter nonsense. Now, sadly, we know things that correlate to autism, but we don't know a single thing that causes autism, and it's certainly not vaccines. So this topic might seem a little bit like, really, is it that important? Yeah, it's really that important, because bad science comes from making correlation into causation without experimentation, which is going to bring us to our next section, a little tiny bit on the scientific method.